I need to know what the center and radius is for a circle. Let's look at this circle here for a moment. Where's the center at? Where's the center? What coordinate would the center be?
0, 0.
The origin, right? Here's a circle centered at the origin. From the center to the edge of the circle, that's what's known as the radius. So I'm going to draw that radius in. Label it R. I need to come up with a way to write the equation of the circle. So let's make use of a shape that we've talked about quite a bit this semester. I'm going to draw a right triangle by dropping the vertical back to the x-axis and the horizontal with the right triangle. Let's label these missing two side legs. Which variable is the horizontal distance? X or Y? X. From the origin to this coordinate on the circle, I would have had to have moved some distance right. Let's call that. What would the other side leg be labeled at? Which variable is the vertical distance? Y. Once I move to the right X, I move up by Y, and I'm on the circle. So which equation give me the side legs in a right triangle? Since I have side legs of the radius R, X, and Y, which equation, which formula represents the side legs in a right triangle? Otherwise known as what? Pythagorean's formula. Let's use these three side legs, X, Y, and R, with Pythagorean's theorem. In the equation of a circle, everything is squared because we're representing that circle using a right triangle. Pythagorean's theorem, x squared plus y squared equals r squared. Equation of a circle, x squared plus y squared equals r. Now this is a very specific kind of circle. Where's the center at again? 0, 0. What if it's not 0, 0? You don't have to have circles who are just centered at the origin always. I might have moved the circle to the right or left or up or down. This is where we have the general form of the equation of the circle. This is a good one to write down because it's going to be most useful. It works for all circles, not just the ones centered at the origin, but all of them. Looks very similar. A couple of little differences. In general, any circle will fit this form, x minus h quantity squared plus y minus k quantity squared equals the radius r squared. The center of a circle is given by h comma k. These two values here correspond to the center of the circle. So the radius of the circle, obviously, given by r. R is for the radius. That's our focus the next couple of days. Take this general form of the equation of a circle and line it. Write the equation of a circle. Give it its picture, give it its description, and so on. Let's try a couple of quick examples. We could just start with something like that. Now we've got a little bit of notes on the form of the equation of the circle. Let's start writing our own equations. In this first question, it says to write the equation of a circle whose center is 3, -1. We've got the coordinate of the center, and the radius of the circle has a length of 4. Center is 3, -1, and the radius is 4. We need to substitute the center in for h and k in this expression here. What's the x-coordinate from our center value? That's the y coordinate. Which one's the x coordinate? Should be 3. I'm going to replace h with 3 in this form of the equation here. So quantity x minus 3 squared. What's the y coordinate for the center of the circle? So replace the k in the form here with -1. Y minus the coordinate -1. Y minus -1 is really simplifying down to double negative, right? K value is -1. Since it's y minus k, y minus -1 just became a positive because of the double negative. What's our radius? Circle has a radius of 4, so it's going to be equal to 4 squared. We're using Pythagoreans, right? Is a squared plus b squared equals c squared, x squared plus y squared equals r squared. So I have to take the radius of 4 and square it. So this should be equal to 4 squared, or simply 16. There's the equation of the circle that matches the description in the question. For a center of 3, -1 and radius 4, equation of the circle to match would be quantity x minus 3 squared plus y plus 1 squared equals 16. Let's try this one. One last quick example here before we try something else. Identify the center and radius of the circle given by its equation, quantity x minus 5 squared plus y plus 2 squared equals 36. The center and radius. Okay. What do you think? What's the center? What comma what? What'd you say? 5 comma -2, but it's -5 and 2. So you're seeing we're switching signs, right? And then notice right away, there's negatives in this form here. So what number am I subtracting? I'm subtracting a 5. The center should start with the coordinate of 5. The signs are just switching. I can also explain it like this. If that doesn't make sense, let me explain it like this. Put the center back to 0 like we started with. What number minus 5 makes 0? What minus 5 makes 0? That's why the center starts with the coordinate at x value of 5. You just get rid of the transformation and put it back to the origin. X value would have to have been 5. Because what number minus 5 is 0? That's going to be 5. What number plus 2 is 0 in that same sense? What plus 2 makes 0? Signs are switching. It's really easy to look at that equation and just say, all right, -5 comma 2, done and done. It's exactly the opposite. Switch the signs, or think about what you have to have x be to make 0 again. What minus 5 made 0? The 5 becomes the function. What's the radius? I see 36. Why not 36? Yeah, it's already been squared, hasn't it? The equation is equal to r squared. So if I see equals 36, what squared makes 36? Just take square roots. Nothing to it. All right, guys, let's do this then. I'm going to pause the recording here, and could you grab your laptops? Here's what I have for you for the rest of the day. A Desmos activity with about 18 or